Before we can move on to trigonometry, we have to recap ourselves on our basic angle and triangle rules. So, we can see that we have different types of angles. We have acute angles, obtuse angles, and reflex angles. Acute angles are from 0 to 90 degrees. Obtuse angles are from 90 to 180 degrees. That's just degree sign there. And reflex angles are from 180 to 360 degrees. We also have special angles like the right angle, which is 90 degrees. And we also know that there are 180 degrees in a straight line. And there are 360 degrees in a circle. So, those are our angle rules. Our triangle rules are these different, the different types of triangles. So we have four main triangles. We have the scalene triangle, which has no angles or sides that are equal. So none of these sides here are equal, and none of the angles are equal. That's what makes a scalene triangle. If two of the sides are equal, we get an isosceles triangle. And you can see that these two sides are the same because we use this notation here to dictate that they're the same length. And you can see that because these two sides are the same, these two angles will be the same. They're x. They're both x, so they're equal. And an equilateral triangle has all of the angles and sides equal. So all of these sides are equal and the angles are equal. The reason I've put 60 degrees is because of this rule up here, that all angles in a triangle add to 180 degrees. And if all the angles are equal, we then get 3x, in which x is our angle, equals 180. Because they're all the same, we know it's 3x, so we get x equals 60 degrees. And finally, we get the right angle triangle. And this is called the right angle triangle because it's a triangle with a right angle. It's quite self-explanatory. So, and this is like a special type of triangle that we're going to look at today. Right. So, let's start with the Pythagoras' theorem. So, if we zoom in to this right angle triangle, because that's what we're focusing on today, we have two sides here, which we'll go over later. So we have this side here, and this can be the opposite slash adjacent, and this can be the adjacent slash the opposite. We'll look at those later. But the line that I want that I want you to focus on is this line, the hypotenuse. And this is the line, the longest line of the triangle is called the hypotenuse. And it's directly opposite from this right angle here. It's the opposite side. So, what we can actually do is if we name that hypotenuse as C, and the other two is AB, it doesn't matter which order the other two are in. So long as if this is a right angled triangle, we can use Pythagoras' theorem, which states that a squared plus b squared equals c squared. And another way of writing this is by square rooting both sides. We get c squared square rooted equals a squared plus b squared square rooted. And since the square root is the inverse of the square, these two cancel out, giving us a squared plus b squared, all square rooted. But either of these formulae will suffice. But it's good to remember this one. Right. So let's do a few examples then. Okay, so example 1 would be something like this. So we have 10, 6, and x. And we know this is a right angle. So the first thing to do would be to mark our A, B, and C. So our A and B would be any of these two. Again, it doesn't matter which way around you put them. But remember, the hypotenuse, so the one opposite the right angle, or the longest side, is C. And now we just go back to our formula. And we can put in our values. So if our A is x squared, B is 6 squared, and our 10, or C is 10. So we get 10 squared. And now we can rearrange the formula to give us 10 squared minus 6 squared. 10 squared is 100, and 6 squared is 36. So we get 64 is x squared. And then we can just square root both sides, giving us 8. So we know that x is 8. Another way of writing this equation would be to move b to the other side to get a. So we have a squared equals c squared minus b squared, or you might have seen it b squared equals c squared minus a squared. These are other versions of the equation that you could use if you don't know a or b. But so long as if you understand this equation here, you'll be alright, because you can just rearrange it like I did here. Let's look at another example. This time, let's look at what that's where we don't know C. So again, let's label our triangle. And now let's use our formula again. Whoops. Equals c squared. And then just substitute our values in. So our a is 4, our b is 3, and our c is x. And then all we have to do is figure this out. So we get x squared equals 16 plus 9. And that gives us 25. So we can just square root to get 5. Bear in mind that we can get different values, different triangles. For example, this triangle could look like this, like that. If that line, pretend all these lines are straight, and we'd have 3 here, 4, and x, like that. You still need to realize that the hypotenuse is this line here, because it's opposite to the right angle. And then obviously if we labeled them in the same way, we get that. Yeah. This can also be used to calculate the length of a line. So if we had 2 points on a graph, so if we say this is 3, 4, and this is minus 6, 2, and then we have a line like this, we can figure out the length of this line, x, let's say. If we consider the height of this triangle, which will be this y value minus this y value, so that's 4 minus 2. I've actually written this wrong. This should be minus 2, right? Because it's underneath the coordinate. It's underneath the x-axis, my bad. Yeah, so it's 4 minus minus 2, which will be plus 2, so that's 6. And then we get 3 minus minus 6, which is 9, like that. And now, because this is a right angle, we have our, we can use Pythagoras to give us 6 squared, it's 9 squared, c squared. So I get c squared equal to 36 plus 81. Or it equals, well, 80 plus 30 is 110. So it's 117. And so c equals root 117. Like so. Right, let's continue. One last thing I want to point out is, Pythagoras in 3D. Now Pythagoras in 3D, you also might need to do trigonometry in 3D, but I'll show how it works. So if you have a cube like so, and then you have a triangle. If I do that. Now this is a cube, and then if we have a triangle going from this point, and this point, we have this triangle here. Right. And now you can see this is in 3D. And if we know the sides of this cube, let's say, or not cube, sorry, let's call it a cuboid. So it can have different sides. Let's say it's 3, 4, and 5, like that. And we know this is a right angle. Well, what we can do is we can find these other two sides using Pythagoras. So let's take this as an example. We're on example 4. Well, if we want to find this side here, x, which is going from here to here, so it's this long line, what we can do is we can figure out this line here using these two values. So that'll just be c, let's use the other version, which is the square root of 3 squared plus 4 squared. In the previous question, we already worked out this was 5. So we know that this is 5 here. And now, since we know this, one of these lengths and one of these lengths, we can actually find x. So we just do the same thing. We say x is 5 squared plus 5 squared. Both these are 25, so we get root 50. Using our surd rules, we can simplify this to get 25 times 2. And then we can split this up, 25 root 2, and so we get 5 root 2 as our answer.